our discussion today, as I've said, no, we'll talk about Newton method, or tinatawag natin tong Newton-Raphson method. Okay, by the name itself, no. Okay. Itong method na to is binuo ni Newton at saka ni Raphson. Okay, dalawang tao to, class, ha. Si Newton at si Raphson. Okay? Si Newton yung uncle ko, si Raphson naman yung kapatid ng uncle ko. Okay? So, yan sila, ha. So, they made the solution na tinatawag natin Newton-Raphson method or simply Newton method. Pero, technically, Newton-Raphson yan. Okay. In the context of numerical analysis, solving an equation f of x means finding the roots of equation or zeros. So, pag sinasabi natin solving the solution or solving the equation, okay, or finding the solution of an equation, ang ibig sabihin niyan, yung, say for example, if we have f of x, ini-equate natin sa 0. And kukunin natin yung lahat ng values ng domain or yung x natin, wherein yung function natin mag-equate to 0. Say for example, meron tayo ditong x squared plus 4x plus 4, no? So, anong roots nito? So, usually, ginagawa natin, ini-equate natin yan sa 0. And then from there, we'll factor this out para makuha natin lahat ng possible values of x na mag-equate sa 0 itong equation. So, normally, ginagawa natin is that we factor out yung dito na side, left-hand side. So, the factored form of that is obviously x plus 2 square. Tama ba? Or x plus 2 times x plus 2. Okay? Then, i-equate natin yan sa 0. Etong una na quantity, equate natin yan sa 0. And that would give us negative 2. The other equation, if we equate that to 0, then we still get negative 2. So, therefore, yung tamang sagot pala dito, or yung roots pala dito, is negative 2. Meaning to say, kapag in-equate natin to, or sinubstitute natin yung value ng x dito to negative 2, so, ang mangyari niyan, we will get 0. Okay. So, negative 2 square magiging positive 4. Ito magiging negative 8 plus 4. Okay, that is obviously, ito makancel yan. Kasi 4 plus 4, 8. Tapos negative 8, magiging 0 na yan. So, therefore, yung roots natin, or yung solution ng equation natin is negative 2 pala. Okay. That is using analytical method, ha. Yung madadali lang ng mga equation, kagaya nito. But, in cases like, mahirap tayong equation. For example, meron tayong ganitong equation. E raised to the power of x minus cosine of x. Okay. Anong possible values of x na that would result to this function be equal to 0? So, what are the possible values of x that will equate this to 0? Okay. So, mahirap na yan, no? We cannot factor this out anymore. Yung kagaya dun sa quadratic or parabolic equation. So, in cases like this, ginagamitan na natin siya ang tinatawag natin numerical analysis. Okay? So, in numerical analysis, okay, we can solve various complex equation. Could it be a linear equation or a nonlinear equation? Okay, sa linear equation, simple lang ito to solve, ha? Because basically, ganito lang yung form niya, no? So, meron tayong example, 5x plus 3 equate to 0. Then, itong positive 3, we can transform that or transpose that to the other side, magiging 5x equivalent to negative 3. And that would make us our x equivalent to negative 3 over 5. So, madali lang yan, hanapin yung possible values of x, no? Pero, in cases that we have a nonlinear equation, so meaning to say, meron na tayong equation na yung exponent na dito is not anymore 1. Kapag 1 yan, linear yan. Kapag more than 1 or 2 or 3 or 4 or 5, then we are now dealing with nonlinear equation. Especially kapag meron tayong ganito. Yung constant natin is being raised to a variable x. Okay, in cases like this is now considered to be a nonlinear equation. Ito na tinatawag natin nonlinear equation. Okay. So, sa ganito, ginagamitan na natin yan ng Newton-Raphson method o tinatawag nating numerical method. Okay? Now, itong mga nonlinear equations by definition class, this includes polynomials of high degree, or trigonometric functions, or logarithmic functions, or exponential functions like this one, no? Or trigonometric functions like this one. These often cannot be solved algebraically or analytically. It requires iterative methods like the Newton's method to approximate. So, itong numerical analysis class, particularly itong Newton-Raphson method, this is just used to approximate, ha? To approximate the solution and not really to get the accurate or true value. Ina-approximate lang natin yung solution niyan, no? Kasi mahirap yan talaga, no? It cannot be solved algebraically, or yung ginagamitan natin yung mga elementary or fundamental techniques, no? Dito, ina-approximate natin using numerical analysis, particularly itong Newton-Raphson. Okay? So, solutions of equation. Ano ba tong Newton's method, no? Newton methods, also known as the Newton-Raphson method, is a powerful technique that uses calculus to find roots. So, dito yon dito, pumapasok yung calculus class, ha? Kasi sa Newton-Raphson method, although iterative methods yan or numerical methods, we still need to determine the derivative or the first derivative of that given function para magamit itong formula na to. So, ito yung formula ng Newton-Raphson method. It starts with an initial guess and uses the tangent line of the function at that point to find a better approximation. So, basically, yung x sub n is our initial or current guess. Itong x sub n, binibigay na yan sa problem. And the next guess would be calculated or denoted by x sub n plus 1 is calculated using this one. Okay? Yung initial guess natin kanina, gagamitin natin yan and then along with the first derivative of the given function. So, ito yung gagamitin natin na formula class and you just need to memorize this one. So, ang mahirap lang dito, dapat alam mo din paano gamitin yung derivative ng given function or hanapin yung derivative ng given function. Okay. Don't worry, we'll have an example later so para ma-visualize nyo or para makita nyo paano sinosolve yung problems ng ganito, no? But, for now, you need to memorize this one. Okay? So, how it works? So, paano ba nag-work ito Newton's method? Okay, you pick a point. Usually, binibigay na to sa problem and I will be giving this one. You choose an initial guess that will become your x sub 0 near the suspected or yung ina-expect mo na root. Okay? Then, draw a tangent line. You find the tangent line to the curve. Meaning to say, you need to find the first derivative of the given function at that specific point. And then, find the intercept, the point where this tangent line crosses the x-axis, becomes your new guess. Okay, yung x sub n plus 1. So, di ba, if we have here, yung formula natin x sub n plus 1, equivalent sa x sub n minus yung f of x, no, sub n, okay, all over yung first derivative ng x sub n, okay. Yung x sub n natin basically is yung x sub 0, no, minus f of x sub 0, then we have here f of x sub 0, no, and that will become our x0 plus 1 or x sub 1. Okay, ito na yung gagamitin natin to solve for the value of x sub 1. Kung kukunin naman natin yung x sub 2, basically x sub 1 to, okay, minus f of x sub 1 over f of x sub 1 prime. Okay, and then kukunin natin yung x sub 3, that is basically x sub 2 minus f of x sub 2 all over f of prime x sub 2, and so on so forth. Yan yung gagamitin natin, no, to solve for the values of yung mga new guesses. Then, you just repeat the process until the value of x stabilize or magko-converge. Meaning to say, mayroon tayong criteria later, no? Or, pag sinasabi natin magko-converge, parang yung value niya is magsistick na lang sa isang value. So, hindi na siya lalayo pa sa yung value na nakuha mo at first. So, magsa-stabilize na yung value mo nakuha. Okay? Okay, later ma-visualize nyo lang din yan, ha? Okay. Now, under Newton-Raphson method, meron tayong tinatawag na first approximation. Now, the success of the Newton's method heavily depends on the initial guess. Sabi dito, kapag wrong yung initial guess mo, okay, or mali yung naging initial guess mo, then guess what? Meron tayong tinatawag na error. Okay? So, kapag, okay, first approximation error ang tawag natin dyan, no? Because the method is local, a poor first approximation can lead the algorithm away from the root or into a mathematical loop. Okay? So, how to find a good initial guess? You can use graphing. Okay? You can graph the equation, no? Then, out from the graph, makukuha mo yung values ng x kung makukuha mo yung values ng x kung saan intercept yung curve natin. Okay? Or you can use the intermediate value theorem. Maghanap ka ng dalawang values, yan yung mag-create ng interval mo. If yung value na nakuha mo at first will become negative and your other value sa interval mo is positive, then there exists a root between that interval A and B, or you can pick the midpoint. Okay? Or you can also, it requires practice kasi class eh. Kasi when we have this physical intuition, kapag nagpa-practice tayo ng problem, so parang nagiging, ano tawag nito? Nagiging master na tayo in guessing the solution of that problem. Okay, kaya tinatawag natin yan physical intuition. Okay? So meron tayong example dito. We'll work on this one muna. Example number 1. Okay, sabi dito, find a root of the equation x minus cosine x with x, initial guess natin, equivalent to 0.8 using Newton-Raphson method up to 5th iteration. So, we'll have 5th iteration. So, baka magtanong kayo, sir, ano yung 5th iteration? So, later, ma-visualize nyo or makita nyo paano ito sinosolve. So, ang gawin natin, isulat muna natin yung formula natin for x sub n plus 1. Diba? Anong formula natin doon, class? That is x sub n minus f of x sub n all over f of x sub n prime. Okay. So, may prime tayo dito, meaning to say, we need first to determine yung derivative natin. So, kukunin natin yung derivative ng ating given function. Ay, by the way, yung given function dito, we have here f of x equivalent sa x minus cosine of x. Tama ba? So, anong derivative nito, class? F of prime x. Anong derivative nito? Derivative of x is 1. Tama ba?
1 plus
Okay.
sine
One
x.
per one.
Derivative ng
One
cosine.
Nine eight.
sin x.
Okay, sine x. So, ito na yung gagamitin natin, no? So, therefore, yung magiging equation pala natin, no? Dito, galing dito, ha? So, lahat ng mga x sub n plus 1 is equivalent sa x sub n minus, ano yung function natin? F of x sub n. Ito yun, di ba? X sub n minus cosine of x sub n. Anong ibig sabihin nito, class? So, lahat ng x dito, isubstitute natin ng x sub n. Then, minus all over ng ito, 1 plus, yung lahat ng x dito, substitute natin ng x sub n. Nakuha? So, that is plus x sine x sub n. So, ito na yung magiging working equation natin, ha? Ito na yung gagamitin nating working equation. So, sa solution nyo, I want to see ganitong process, no? Maglagay kayo ng number of iterations. Dito, may iterations kayo. Okay? Then, gawa kayo ng parang line. Okay? Gawa din kayo ng line dito. Ganyan. So, meron tayong first, second, third, fourth, and ilang iteration yon? 5th iterations. Tama ba? Gawa din kayo ng line. Dito. 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 Tsaka, ito. Last one. Okay, ganyan, no? Dito, lagay kayo ng x sub n. Yan. And then, gawa kayo dito ng x sub n, no? So, ano yung initial guess natin? Then, dito, okay? Dito, gawa kayo ng x sub n plus 1. Okay? Yan ang second guess natin, no? Then, dito na yung magiging okay na yan, okay na yan. Dito na yung lahat. X sub n tapos x sub n lang. Okay, or pwede nyo din ilagay, no? Pwede nyo din ilagay x sub n plus 1 equivalent sa ito. X sub n minus cosine of x sub n all over 1 plus sine x sub n. Okay, yan na yun gagamitin natin na table. Okay, so sa solution nyo dapat makita ko tong ganitong table. Okay, etong gagawin natin class ha. So, ang gagawin natin is that, okay, kukuha tayo na, di ba yung initial value natin, so, first iteration, okay, yung value natin ng x sub n is basically yung x sub 0, no? So, that is 0.8. Dito, ilagay natin 0.8. And then, kukunin natin yung x sub n plus 1. Anong gagamitin natin? So, for x sub n plus 1, basically, i-evaluate natin yung 0.8 minus 0.8 cosine of 0.8 all over, okay, all over 1 plus sine of 0.8. So, evaluate natin to class. So, anong sagot nito? So, sa calculator nyo, maglagay na lang kayo directly. Itong equation na to sa calculator nyo. Tapos, hindi nyo na yan i-change pa. So, make sure na naka-region mode kayo kasi we are dealing with trigonometry here. X minus, so wala man tayong x sub n, no? So, x yung magiging x sub n natin sa calculator, ha? Minus cosine of x. Okay? Then, all over natin yan by 1 plus sine of x. Okay? So, makuha natin dito is equivalent sa calc natin to. Okay, yung value na gagamitin natin is 0.8. Ang makukuha natin na value dito is 0.73985. Okay. So, kukunin ko lang to class. Lagay ko na lang to dito. Okay, meaning to say yan yung yan yung solutions na ating ginawa, no? So, ito, that would give me a value of 0.7, okay, sorry, wala, 7.39853. So, sa solutions ninyo, dapat, I want 6 decimal places, ha? Now, itong x sub n natin, ito naman yung gagamitin natin dito na naman. So, yung x sub n natin na yung nakaraan will now be equal sa x sub n na ating bagong value. Okay, ganito. So, ito naman yung gagamitin natin dito. Okay, para makuha yung next value for x sub n plus 1. Okay, 0.39853 minus cosine of 0.739853 all over. Sorry, wala. Okay, all over. Ito. 1 plus, meron dito ha. 1 plus sine of 0.739853. Okay. So, balik kayo sa calculator ninyo. Huwag nyo lang tong i-erase, no? Calc tayo ulit. Ang gagamitin naman nating value is itong value na to. 0.739853. So, ang mangyari niyan, that was equivalent to 0.73985. Okay, yan yung value natin, no? So, itong value na to, gagamitin natin yan for the third iteration. Okay, itong value na to, copy natin dito, yan yung gagamitin nating value for the third iteration. So, similar lang ha, similar lang yung magiging method dito, yung value ng ganito, magiging ganito na naman, tama ba? So, same lang ha, same lang yung magiging equation natin. Lagay ko lang dito same. So, calculator na lang yung paggawa natin, no? So, eto, balik tayo dito ulit. Okay, balik tayo dito, calc na yun. And then, ito yung gagamitin natin na value. 0.739085. So, ang value niyan is 0.73908.5 din, di ba? No? 6 decimal places, no? Tingnan nyo. So, kung gagamitin natin yan dito ulit, then we still will get still 7.08985. So, ang change lang dito is yung mga decimal places dito. Kung kukunin natin yung exact value. So, kung yan naman din gagamitin natin dito, so basically, we will end up with the same number lang. Tama ba? So, therefore pala, at fifth iteration, yung value, whatever value ng x sub n plus 1 mo, which is, in this case, ito, tama ba? Ito na yung magiging sagot natin. Okay? So, therefore pala, yung root natin, yung x pala natin, is equivalent sa 0.739085. Okay, ito na yung magiging sagot ninyo. Now, to prove that is the solution of our given equation, so pwede nyo man yan i-calculator, no? Gawin natin is, i-check natin sa calculator. Isulat natin sa calculator, x, okay, alpha x, minus cosine of x, no? Okay. And then, di ba sabi dito, we find a root. We find a root close to 0.8. So, meaning to say, dito, equate natin yan sa 0. Okay. Kukunin natin yung value ng x na mag-0 yung itong equation na to. Then, once we shift solve, okay, so shift solve for x, yung initial guess dito na 0.8, yan yung ating ilagay dito. Okay. Once we press equal, ang sagot na ibibigay niya is yung value na nakuha natin dito. Okay? So, ang sagot diyan is 0.739085. Yan yung value ng x wherein yung ating equation na x minus cosine of x is magzi-0. So, to prove that one, so lagay natin ha. So, yung x, sagot natin dito is 0.739085. So, let's subtract cosine of that value, 0.739085. Okay. Makukuha natin value dapat close to 0 if not exact. Okay. That is equivalent to close to 0. Tama ba? Close to 0 na yan class o 0.00 something. Okay. So therefore, yung sagot pala natin dito is this one. Okay. Ito na yung magiging answer natin. Nakuha ba? So that is basically yung Newton-Raphson method. Okay. I hope nakuha nyo, no? Okay. Now, I want you to try this one. Okay, try answering this problem. Hold on. Okay, I want you to try answering this example number 2. Okay, this one. So, you find a root of the equation e raised to the power of x minus 5x with initial guess equivalent sa 2 using Newton-Raphson method up to 4th iterations. Okay? Sige. You try answering this one. I will give a deadline for this one which will be 11:59 tonight. Okay? Okay?